Example 4. Modeling amount of daylight as a function of time of year. Figure 9 shows graphs of the number of hours of daylight as functions of the time of year at several latitudes. Given that Philadelphia is located at approximately 40 degrees north latitude, find a function that models the length of daylight at Philadelphia. Now, if you notice that each curve resembles a shifted and stretched sine function, by looking at the blue curve, we see that at the latitude of Philadelphia, daylight lasts about 14.8 hours. So here we can say that daylight lasts about 14.8 hours. And then which is on June 21st. And then on December 21st, we can see that it ended up going down to approximately 9.2 hours. So the amplitude of the curve, which is the factor by which we have to stretch the sine curve vertically, is the following. A is going to equal half of 14.8 minus 9.2, which gives us an amount of 2.8. So that represents the amplitude. Now, by what factor do we need to stretch the sine curve horizontally if we measure the time t in days? Well, because there are about 365 days in a year, the period of our model should be 365. But the period of y equals sine t is 2 pi. So the horizontal stretching factor would be b, which is equal to 2 pi over 365. Now we also notice that the curve begins its cycle on March 21st, which is the 80th day of the year. So we have to shift the curve 80 units to the right. In addition, we shift it 12 units upward. Therefore, we model the length of daylight in Philadelphia on the teeth day of the year by the function of the following. So this is our function, but before, let's take a look here. Y is equal to a times the sine of b times x plus c plus d, where a represents the amplitude, we have the period, we have the phase shift, which is c, and the vertical shift is d. So here is our formula. Y, which is equal to the amplitude times the sine of the period times x minus however it is shifted. In this case, since we're shifting it to the right, it's going to be minus, and then plus shifting it up or down. So we know the value of a represents 2.8. We know the value of b represents 2 pi over 365. We know that c is equal to 80, and we know that d is equal to 12. Now again, because this is shifting to the right, then this means that we're going to have y is equal to a times the sine of b times x minus c plus d. But we need to write this in terms of our latitude and the time. So we have L of t, which is equal to 2.8 times the sine of 2 pi over 365 times t minus 80 plus 12.